This particular practice test is a good example of where they throw in some things, as they always do, that are just different than anything you've seen before. They're very good at that, so you just keep going. As long as you're writing, you're doing fine. If you stop writing, you're stuck, you move on. So anyway, it says, find all intervals where g is negative, or less than or equal to 0. So I have this formula here. If I start at x equal -4, I'm going to want to switch this integral like I did previously. So -1 times the integral from -4. That's if I'm finding g of -4. So this problem is already feeling like I'm stuck, so I've definitely skipped forward. So that would be g of -4. I've already done that. And that ended up being this area. So here's f of t dt. So we have the -1 times -4, and then it was plus 4 plus 4 again. The good news about this problem is it doesn't say you have to justify, which means I don't have to show reasons, I just need to come up with the right answer, because it didn't say I had to justify. So let's see, if I have an x value of -4, I'm definitely going to get, this will become for -4. So starting at x equal -4, the value of g is definitely negative. And now I just have to think about what happens as I plug in things like -3 or -2. Oh, now I see the pattern. From here, okay, so initially this area added to this area to give me 0. And then I had the -1 out front, and then including that with this area, so that counted as a +4. Multiplied by the -1, I got negative. So as I start integrating like this, like at different x values, say I start here at -3, this will no longer be enough to counterbalance this. Now remember, there's a -1 out front, so everything's switching. So it's as though this is going to count negatively, and this counts positively. So there's much more negative than positive if I integrate. So I started at -4, the answer was -4. If I integrate further up, I'm going to get even more negative. So I definitely know that all the way to here, so from x equal, this problem is taking way too long, to x equal -2, I'm definitely getting all negative. In fact, I've done that already, so I look back here, g of -2 is -8. So the graph of g starts at the y value of -4, it goes down to a y value of -8. Should have known that because here g prime is negative, which means g is decreasing. Then, when I start integrating at -2, g prime is now positive. So g prime is positive, so g is going up all the way until I get to 6. So g is now going up. when I integrate, okay, I already know I'm at negative 8. So if I did g of 2, didn't do that one earlier, let's do that real quick. G of 2, that's going to be the integral, oh, that one's easy, from 2 to 2 of f. So that's equal to 0. So that means g itself stayed negative until we got to a y-coordinate of 0. I need a better picture of all this. So here's what g is doing. G begins at an x-coordinate of negative 4, and g of negative 4 is negative 4. So it actually matches the graph of f, which is kind of weird, but oh, this was a negative. Messed up there too. So this is positive, this is negative 4, and then g, so g starts there, g goes down somehow, we don't know the shape, we haven't taken time to think about it, until we get to 2 comma negative 8, because we figured out that g of 2, negative 2, this problem is taking way too long, g of negative 2, the value of g is negative 8. Then we know that g starts to go up, because from x equal negative 2 until x equal 6, g prime is always positive. So g is always in, g prime is positive, so g is always increasing. So now g goes back up until we get to 6 comma 0, because we figured out, oh no, wait a minute, 2, sorry, 2 comma 0. So 2 comma 0, that's where g stops. No, it's still going up though, but that's where g stops being negative. So I found the first interval. So I could write that and put it in a box to get that point. So g is less than or equal to 0 for negative 4 until I get to from x equal negative 4 all the way to x equal 2. So put a box around that so the grader can find it, because I've just got work kind of everywhere. Don't have to justify anything, I just have to get the right answers. So I have that. So I keep going. G is going to just keep going up until I get to 6. I found that already. G of 6 was 8. So G keeps going up. So over here my picture of G. So G keeps going up until we get here to 6 comma 8. Then for the remainder of the time we have a G prime graph that is always negative. So G will always be going down now. Let's go find what happens at 10. So G of 10 is going to equal the integral from 2 to 10 of f. From 2 to 10, perfect symmetry. The area above perfectly matches the area below. So that's going to equal, so G of 10 is going to equal 0. So now I've figured it out. So starting at x equals 6, G goes down. And when we get to x equal 10, that's when the value of G is 0. So that's back over here. Let's do white. So that's at 10 comma 0. Then because G prime is negative after that, G will continue to decrease. This is G prime being negative, so G goes down. We already figured out that at 12, x equal 12, the value of G is negative 4. So I can finish off the problem now. So this is back to like about here. This is G again I'm drawing. 12 comma negative 4. So I write the other answer, which is, I'd probably grab my eraser real quick and just go like this. And 10 to 12. They give you 1 point for each interval that you find. So the problem is worth 2 points, definitely a hard-earned 2 points. 1 point for each interval that was found. You don't have to do any explanation though, so if you can do all that in your head and get the right answer, they will give you the 2 points. I was trying my best to explain it, but